In this video, we're going to learn how to do stoichiometric calculations that include limiting reagents. So first we need to understand what a limiting reagent is versus what an excess reagent is. And here's an example of a reaction. H2 or two H2s plus O2 gives you two H2Os. Let's just say that we have 4 hydrogen molecules and 3 oxygen molecules, and we mix them together and form water. So if I take these 2 hydrogen atoms, or this H2 molecule, they'll react with one of the oxygens in O2, and I'll get H2O. Let's say that I take these 2 hydrogens and I react them with this oxygen, I'll get another H2O. Let's say that I take this hydrogen molecule and react them with this oxygen, we get a third H2O. And let's say I take these 2 hydrogen atoms, this hydrogen molecule, and react it with this oxygen atom, and I get a fourth H2O. Just looking at this, you can see there is O2 left over. So actually, we still have a little bit of O2. What we can say is that our H2 is limiting. This is the limiting reagent, Lr. And the oxygen is the excess reagent, ER, if you will. Limiting reagent is what limits the amount of product you get, meaning that it completely runs out. The excess is what does not limit what you end up with. It's something that there's still a little bit left over when you're done with the reaction. So in this particular case, we had a limiting amount of hydrogen and we had an excess of oxygen. So how can we do calculations that include limiting reagents? Here's what we can do. We can say that in this problem, we have 4.04 grams of hydrogen and 16.0 grams of oxygen. What I can do is I can say that, say we have 4.04 grams of hydrogen. I can convert this to moles. I can next convert the moles of hydrogen to moles of water that would form, since we're asked what mass of H2O can form. Then I can go to grams. This is a simple mass-mass problem, the type of which we've done before. But I'm also going to say we have 16.0 grams of O2. We're going to go to moles of O2. We're going to go to moles of H2O. Then we're going to go to grams of H2O. So what we're doing is we're doing 2 mass-mass calculations. The first one is going to be 4.04 grams of H2. We're going to basically say, let's assume that this is the limiting reagent. That assumes that there's an excess of H2. Let's see how much water we could form if we're assuming that the H2 is limiting. So if H2 is limiting, what is the amount of H2O we could get? Just sort of plowing through this quickly. Sorry, that was 2.02 grams per mole of H2, just the atomic mass, times 2. And finally, we have 18.02 grams of H2O. For every mole of H2O, that's just the molar mass of water taken by adding 2 hydrogens, atomic masses, and 1 oxygen. So what we're going to get here is 36.04 grams of H2O that would be formed assuming the hydrogen is the limiting reagent and that the oxygen is in excess, which we do not know. But we're going to do the same thing now for oxygen. And what we'll see, oxygen, the atomic mass is 16.00, so the molar mass of O2 is 32.00 grams per mole. We'll say that we have 2 moles of H2O that are formed for every 1 mole of O2. And then we'll multiply this by 18.02 grams of H2O that are formed for every mole. And what this brings us to is 18.02 grams of water. Now, what is the answer to this problem? It's going to be the smaller amount, because what we found is that we have enough hydrogen to form 36 grams of water if there's sufficient oxygen to react with it. However, we have only enough oxygen to form 18 grams of water, assuming there is enough hydrogen to react with it. Bottom line is, whatever the smaller number is that you get, that's the actual amount that is formed. What we've proven is that O2 is limiting, and we only have enough O2 to produce 18.02 grams of water. Sorry, it's 18.02 grams of water. We have an excess of hydrogen because we had enough hydrogen to make 36 grams of water, and yet we only got 18. Oxygen is limiting, hydrogen is in excess, and this is the actual amount of water that is formed. So how do you recognize a limiting reagent problem? Quite simply, if you're given actual amounts of multiple reactants, then you can tell it's going to be a limiting reagent problem. If you're told, here's an amount, a number of grams or moles of something, and the other starting material is in excess, then classic stoichiometry. But again, this is limiting reagent in this problem because we are given actual amounts of both substances, and just based on that alone, you can't tell which one is going to run out first. In this case, the oxygen has run out first. We got 18 grams of water. We did not get any more because the oxygen is limiting and the hydrogen is in excess. Hope this video has helped. Please feel free to leave any questions or comments in the comment section below.